Okay, so here is a little summary of the centers of a triangle. There are three different types of centers that we consider: the centroid, the orthocentre, and the circumcentre. And in the summary itself, all of this is on one page. I have the centroid on the left, the orthocentre in the middle, and the circumcentre on the right. But I've split them across 3 pages here to give me a bit enough room to do some scribbling, and then we'll compare the 3 at the end. So for the centroid, what you need to know for each center of a triangle is what lines intersect to give you that center. So for the centroid here, it is lines from a vertex to the midpoint of the opposite side. Those lines meet at the centroid. So see all of these lines, they go from a vertex to the midpoint of the opposite side. Okay, and all you need really are 2 of those lines going from a vertex to the midpoint of the opposite side. And 2 of those lines will meet at the centroid. If you draw in the third, it will also pass through the centroid. Now, for the centroid, there's actually a very nice formula for calculating the coordinates of the centroid. This is the formula, and you need to know this because it's not in your log tables. So here's a little hint for remembering it. It is the average of the 3 x coordinates of the 3 vertices and the average of the 3 y coordinates. Maybe that's one way to remember it. Or another way is it's very like the midpoint formula, only you have an extra coordinate in each, or an extra term in each of the coordinates. Okay, now a fact about the centroid, and that is the centroid divides the lines from vertex to midpoint in a ratio of 2:1. So these are the lines that we were talking about earlier that all intersect the centroid. So they go from the vertex to the midpoint of another side. And the centroid itself divides any of those lines in the ratio 2:1. Again, you need to know that. If there's something I'm mentioning that is in the log tables, I'll always tell you what page it's on the log tables so that you don't have to remember it, but all of these facts you will need to know. Okay, moving on to the orthocentre. So what lines intersect to give you the orthocentre of a triangle? They are the lines from a vertex perpendicular to the opposite side, or they all meet at the orthocentre. So what you see here is a line passing through a vertex. So a vertex is one of the points of the triangle, and it meets the opposite side at a right angle. And if you drew even 2 of those lines and you found their point of intersection, you'd find the orthocentre. And often actually you're given coordinates of the 3 vertices and you have to find the orthocentre. It's a little trickier than the centroid. There isn't a formula you can just plug your points into. You have to construct each of these lines. And you use the fact that you know a point on the line, and then because you know the vertices, you can find the slope of the opposite side and then find the slope of the perpendicular line. Now, an interesting fact about the orthocentre: for a right-angled triangle, the orthocentre is actually at the right angle, because when you think about it, if I drew a line, I'm going to put them in here in bright pink. Okay, so if I go from this vertex and I meet the other side at a right angle, I will meet here roughly. And then if I go from this vertex, maybe I'll do this in the color yellow, go from this vertex and I go to meet the opposite side at a right angle, it looks like that. And then if I go from the vertex there at the right angle and I meet the other side at a right angle, well, already 2 of those lines that will determine the orthocentre meet at the right angle. The third also meets at the right angle, the blue one, because the vertex at the right angle is part of that blue line. So that is a fact that you want to know, that in a right angle triangle, the orthocentre is at the right angle. And then, like I've drawn above, a triangle with no obtuse angles. So this one up here had no obtuse angles. Here we have a 90-degree angle. And what about a triangle with an obtuse angle? And the fact is, the orthocentre will lie outside of the triangle with an obtuse angle. So the triangle I'm focusing on here is this navy one. Okay, so the pink lines are going from the vertex to meet the opposite side at a right angle. But if you take, for example, this vertex up here, if I draw a line that is perpendicular to the opposite side, I'd have to extend the opposite side in order to draw such a line, okay? Because I can't, as it stands, with the length of this opposite side, there isn't enough length to it to draw a line that's perpendicular to it that passes through it. So that's how you end up with this line. And then if you take, for example, this coordinate, that is opposite to this blue side. But if I want to draw a line that passes through the blue coordinate and is perpendicular to the blue side, I need to extend the blue side. Okay, and if I do that and draw a line that goes through the vertex and is perpendicular to the opposite side, I get this blue line. Already they have met at the orthocentre. All right, but just to confirm with the final line, so the final line will pass through a vertex and it'll go through the opposite side of that vertex at a right angle, and that's what this green line is doing. If I extend it far enough out, it'll pass through the orthocentre. So just something to remember, if you have a triangle with no angles greater than 90, the orthocentre is inside of the triangle. If you have a triangle with a 90-degree angle, a right angle, then the orthocentre is at the right angle. And then if you have a triangle with an obtuse angle, then the orthocentre will be outside of that triangle. Okay, and then the circumcentre. What lines intersect to give you the circumcentre? The lines that intersect at the circumcentre are the perpendicular bisectors of each edge. They meet at the circumcentre. Now, a perpendicular bisector of a line segment. So suppose this is a line segment. A perpendicular bisector bisects the line segment, which means it divides it into two equal pieces, and it is perpendicular to the line segment. So it's something like this that is perpendicular to the green line segment, and it's dividing it up into two equal pieces. The two pink dashes indicate that they are of equal length. So for my given triangle here, if you draw a perpendicular bisector of each side, even two alone is enough to give you the circumcentre. And if I draw in the third, then they all meet at the circumcentre. And the fact about the circumcentre is that the circumcentre of a triangle is the centre of the circumcircle, and the circumcircle is a circle that passes through the three vertices of the triangle, as you can see down below here. And you'll notice that, so if the circumcentre is the centre of that circle, if I draw a line from the centre out to meet the circle, and suppose I meet it at one of the vertices, because I might know something about that vertex, that will be a radius. Okay, again for circumcentre, the same as with orthocentre, there is no formula like the centroid, so you have to find the equations of two such lines, a perpendicular bisector of one side, perpendicular bisector of another, and find their point of intersection. Okay, so putting all of that together, what are the lines that intersect? So I kind of want to just wrap it all up here and say, for the centroid, so I suppose there are three concepts. There are lines that go through vertices. There are lines that are perpendicular to the other side. And then there are lines that, what's the third? Okay, so here, oh yes, lines that pass through the midpoint of the other side. So bisect opposite side. Opposite side. Okay, so for the centroid, the lines that intersect to give the centroid pass through a vertex and bisect opposite side. So you see it there, pass through a vertex and bisect the opposite side, you have equal pieces on either side there. For the orthocentre, they also pass through the vertex, but they meet the other side at a right angle. So they are perpendicular to opposite side. That little sign means perpendicular to opposite side. And then for the circumcentre, the lines that intersect to give the circumcentre don't pass through a vertex. They do bisect a side and they are perpendicular to a side. So really there are only three things to remember, and I actually find it's easiest nearly to try to recall all three, centroid, orthocentre and circumcentre at once, than to recall just one of them, okay? So centroid has 1 and 2. For the orthocentre, it's lines that satisfy 1 and 3, and for the circumcentre, lines that satisfy 2 and 3. And that's a bit vague, but you've already seen it earlier on in a bit more detail.